Hello and good morning. We are going to exhibit the time series data analysis on the same data that I have shown you in the previous videos. That is a panel data of Indian banks, three Indian banks. Code 1 stands for SBI, code 2 stands for Bank of Baroda, and code 3 stands for Punjab National Bank. The data is uploaded here as you can see in EViews 8 version, and now we are going to execute the work. We will first go to quick, and in quick we will go to estimate equation. Then we will write our equation. First is our dependent variable. We want to predict the earning per share of the bank. So earning per share. Then comes small c, which is the unknown and undefined relationship. Then comes the x variables or independent variables. AA average assets, BV book value, GNPA gross NPA, GRHM Graham number, which shows intrinsic value of a company, IEII interest expense, interest income, net interest margin, PAT, PB, PE, ROA, ROI, and total assets, TA. Now we will see this panel option will pop up. Since most of these variables are accounting variables, so in the panel option we will take cross section fixed and period fixed. I will short different videos to make you understand where we take fixed effect, where we take random effect, and where we take a mix of fixed and random effect, and where we ultimately go for generalized method of moments. But today we are going to do a simple work based on fixed effects, where the cross section is also fixed and the period is also fixed. Specifications I will go once again. This will be method will be ls least square. You can see the result in front of your eyes. So what I'm going to do to make it easy, I will copy this and put it in an Excel. So first come first, what is this capital C? This capital C is nothing but intercept. So imagine an equation y equal to c, that is capital C, plus bx. So if x, value of x is 0, then bx becomes 0, then y becomes c. So this c is the minimum value of y when x is 0. So intercept is a constant, and intercept is the minimum value of y variable or dependent variable when all the x variables are 0. That is why the probability is of no concern, because it cannot have a probability. It is a constant. A constant number is always having 100% probability, so we can ignore this. Okay, now you must have seen what I have done. I have just converted into percentage. Normal regression we take errors up to 5%. But since this is a panel data considering so many banks, plus this is a data for almost 10 years for each bank, so much of data cross sectional, that is why we are allowing a little higher error so that we can reach the conclusion better. So we are allowing approximately 15% error, that is we can take the probability value up to. So let us calculate the occurrence value here, that will make you work easy. Occurrence is 1 minus probability. So I'm just identifying the green zones. So if we carefully observe, we have got four variables which are strongly indicating that they have a strong relationship with earning per share of that particular group. First one is book value. Second one is Graham's number, invented by Benjamin Graham, which is basically the intrinsic value of any company, indicating the intrinsic strength. Third is PAT, profit after tax, and fourth is ROA, return on assets. So these four are going to be our main linchpin in order to predict. Coming back, we will see how robust is the prediction. So we will look at Achaic information criterion, Schwarz information criterion, and Hannan Quinon. As you see, all of them are below 5. So as I taught in the previous videos, if it is below 5, though it is comparative, because suppose if some friend of yours calculate it below even 1, then that particular calculation will be better than this calculation shown right here. However, in this case, whatever is there in front of us, we can safely suggest that this is quite robust, because the AIC, SC and Hannan Quinon values are below the cutoff of 5. However, we cannot say it is 100% robust, because there could be studies on the same banks with different variables and the same bank with different time zone, where someone else with a different technique, if they find lower values of AIC, Schwarz and Hannan Quinon, then obviously that will be better. We can just see loosely the R square, though R square is not very important here, but it is the OLS end of the day, ordinary least square. So you can see here, so it is almost 1, close to 1. That means it is quite strong prediction. So let's see the estimate first. Rather forecast first. So this is our forecast plot. We have to see only one thing. With this particular work, can we forecast? So today I will tell you some magic theory of forecast, what we generally use in the industry. There are these four parameters, we take it very seriously: root, mean square error, mean absolute error, mean absolute percent error, and tail inequality coefficient. So these four actually, unfortunately I can't copy from here. So just remember, these four we have to follow a formula called 1151. That means if root mean square error is below 1, if mean absolute error is below 1, if mean absolute percent error is below 5, and if tail inequality coefficient is below 1, then it is really robust and we can use it for forecasting on a real time. Another interesting thing here is the bias proportion is 0, so there is no bias as such in this work. So now let us see the residuals once again. Residuals, just a small recap, is the difference between the predicted and the actual. So you can see one very interesting thing here. Actual and predicted. Actual is the red bar, predicted is the green bar. Red and green are almost overlapping each other. So you can see a tinge of red somewhere here, somewhere here, somewhere here. Because the R square is so high, close to 1, that means the actual and fitted are almost equal. So residuals are also here shown in the blue color. You can clearly see the residuals here. Interesting thing to note here is, I will show you, this 1 belongs to State Bank of India, this 2 belongs to Bank of Baroda, and this 3 belongs to Punjab National Bank. But interesting part is, if you see SBI, here also actual and fitted are overlapping. If you see Bank of Baroda, here also actual and fitted are overlapping. Or if you see Punjab National Bank here also actual and fitted are overlapping. So that means this is uniform. It is uniform, it is not specific. So I will click stats to go back to the stats menu and view representations, and this is the equation in representations of this EPS predictor. So this is a EPS predictor, and this minus 38.67, this is the value of C, that is the constant value with a minus sign. So this is a very simple straightforward case of panel data regression with a fixed effect model, cross section fixed and even longitudinally also fixed, time series fixed. However, in the coming videos I will show you the other variations of this also. So panel data is not so simple, panel data can be anything else. Just remember one thing, this work is done on a balanced panel. Thank you for watching. Please subscribe for more updates and more videos which are coming up in Econometrics Made Easy series. Thank you.